So this abstract is the evaluation of dietary acidifiers on growth performance of nursery pigs. Now these experiments were a follow-up to some of those which I have previously presented. And the reason that we have interest in these acidifiers is that they are being increasingly used in nursery pig diets, and this is both in Europe and North America. Now, there are many different sources that are available of acidifiers, and these vary in pH and also potency. Acidifiers have resulted in improved growth performance in some trials, but not others. Now, the recent research that I discussed here at Kansas State has shown that there were no improvements in growth performance when acidifiers were fed in the university research environments. Now, this brings us to the idea that perhaps the university environment may not be the best area to test these. And really, we're not exactly sure why the responses differ. But that was, let me start this slide over. So acidifiers are increasingly being incorporated into nursery pig diets, both in Europe and North America. Now, there are many different sources available, and these sources of acids vary in pH, they vary in potency. Now, they have resulted in improved performance in some trials, but not in all trials. Now, recent research that we conducted at Kansas State has shown that no improvements in growth performance occurred when acidifiers were fed in the university research environments. Now, the explanations for these different responses have been proposed, but they are not still fully understood. Now, the objective of these trials was to determine the effect of 3 commercial acidifiers on growth performance of nursery pigs housed both in the university and field conditions. Now, looking at the materials and methods for Experiment 1, Experiment 1 used 280 nursery pigs in a 28-day trial. These pigs were initially 7.3 kilograms in body weight. There were 7 pigs per pen and 10 pens per treatment. Now, this trial was conducted at the Kansas State Swine Teaching and Research Center in Manhattan, Kansas. So again, under university research conditions. Now, all diets were prepared at the K-State Animal Science Feed Mill. And then, moving on to experiments 2 and 3, experiment 2 used 1,728 nursery pigs. Now, these pigs were initially 5.8 kilograms, so they were quite a bit smaller than under the university conditions. And we started them on test 10 days post-weaning, and there were 48 pigs per feeder and 24 pigs per pen. For experiment 3, there were 1,800 nursery pigs used, and these were initially 7.4 kilograms, so again, heavier than what we used in experiment 2. These pigs started on test at 13 days post-weaning. There were 50 pigs per feeder and 25 pigs per pen. Now, each feeder was available to 2 adjacent pens. One of those pens was a barrow pen, and the other was a gilt pen. There were 9 replicate feeders per treatment, and this trial these 2 trials were conducted at a commercial nursery research facility, and all diets were fed in meal form and manufactured at a commercial feed mill. Now, there were 4 dietary treatments. There was a control, which contained no acidifier, and then we either added 0.5% Vivo Vital, which is a benzoic acid product made by DSM Nutritional Products. The third treatment was control plus 0.2% Chemgest. Now, Chemgest is a blend of phosphoric, fumaric, lactic, and citric acid made by Chemin Industries. And the fourth treatment was a control plus 0.05% Butapearl. And Butapearl is an encapsulated butyric acid. Now, 2-phase diet series was used in each trial. Now, in experiment 1, the treatment diets, which we saw in the previous slide, were fed all the way from day 0 to 28. However, in experiment 2, the treatment diets were fed from day 0 to 14, and then a common diet was followed up from day 14 to 28 to monitor subsequent performance. For experiment 3, treatment diets were fed throughout the entire 28 days. Now, pigs were weighed and feed disappearance were measured every week to calculate average daily gain, average daily feed intake, and feed efficiency. For the statistical analysis, the data was analyzed using proc mix procedure and SAS. Either pen in experiment 1 or feeder in experiments 2 and 3 were used as the experimental units. Now, differences were determined using the p-diff statement and stats, and differences were declared at p is less than 0.05, and trends were declared at p is less than 0.10. I want to look at the diets briefly before we go into the results. For experiment 1, shown on the left, again, these were corn and soybean meal-based diets. They contain 10% spray-dried whey, 1.2% fish meal, as well as 1.2% blood cells. And then for phase 2 of the trial, it was corn and soybean meal-based with just synthetic amino acids added. Now keep in mind that these are the control diets for each phase, and again, one of 3 acidifiers was added to the control diets to make each of the 4 treatments. Now looking at experiment 2 and 3, which were the commercial trials, again, we fed complex diets during phase 1. These did include 15% DDGS, 10% spray-dried whey, and 1% blood cells. And then in phase 2, it was a corn and soybean meal-based diet with 15% DDGS. The analysis of these diets was fairly simple. Moving from phase 1 to phase 2 in each trial, the lysine level was slightly reduced, going from a 1.3% SID lysine down to 1.26% during the commercial trial. And then in the field trial, lysine during phase 1 was 1.35% and then reduced to 1.3% in phase 2. Again, the appropriate amino acid ratios were used for each amino acid ratio, and metabolizable energy and calcium were fed as needed. Moving on to the results of the experiment. First, we're going to look at experiment 1. So again, it was conducted in a university setting, and we're going to focus on days 0 to 28. Now, the main reason we're focusing on day 0 to 28, which was the overall trial, is because the individual phase data was also very similar to that of the overall trial. So for sake of time, we'll focus on day 0 to 28. Now, as you can see, the pigs fed the control diet are shown in the yellow bar, and the pigs fed the other 3 diets containing one of the 3 commercial acidifiers are shown in the blue bars. When looking at average daily gain from experiment 1, there were no differences when any of the acidifiers were included. Then moving on to feed efficiency for experiment 1, again for the overall trial, it was very similar to average daily gain, where there were no differences among the 4 treatments. So now I want to actually move into experiment 2. And in experiment 2, we're breaking this down by phase. Now, we're going to look at first day 0 to 14. And remember that experiment 2 was conducted in a commercial facility, and treatment diets were only fed from day 0 to 14, where a common diet was fed beyond that point. First, looking at average daily gain, notice that pigs fed any of the 3 acidifier diets did have increased average daily gain compared to those fed the control. And a similar result was found for feed efficiency, where pigs fed Viva Vital, Chemgest, or Butapearl had improved or increased gain to feed compared to those fed the control diet. Now, still on experiment 2, we're now going to move into the overall data. So this includes the 0 to 14, which you saw, but it also adds in a 14 to 28 common period. Here, we did see a tendency for pigs fed Viva Vital to have increased average daily gain compared to the control. Now, this was P as less than 0.10. And for feed efficiency, there were no differences among the 4 treatments. Now, at this point, we had seen no response to acidifiers in the commercial environment, which was experiment one. The university setting, which was in experiment one. Let me start over on this slide. So at this point, in experiment one, under the university conditions, we did not see any differences when including acidifiers in the diet. However, when we took those diets to the field in experiment 2, we saw improved average daily gain and feed efficiency. So then we wanted to follow this up with experiment 3, where instead of feeding the treatment diets only from day 0 to 14, we decided to extend it out all the way from day 0 to 28. So here, looking at another commercial trial where the acidifiers were fed from day 0 to 28, unfortunately, adding acidifiers into the diet did not influence average daily gain in this trial. And then looking at feed efficiency, we also did not see a difference among the 4 treatments for gain to feed. So in terms of conclusions, really the response to dietary acidifiers varied greatly among experiments. For example, in experiment 1, there were no beneficial effects on growth performance. Then, moving to the commercial environment for experiment 2, the pigs fed acidifiers did have improved average daily gain and feed efficiency. However, again, in the same commercial facility, in experiment 3, there were no beneficial effects on growth. Now, the reason for these inconsistent responses are not fully clear, but they may be due to health status, perhaps age or starting weight. Notice that some of those did vary between experiments, so that may be influencing the results. But really, further research is required to effectively incorporate acidifiers into nursery diets. I want to thank you very much. Thank the K-State Research and Extension team here, as well as DSM Nutritional Products for assistance with this trial and also partial funding.